Welcome back. Now we're going to continue graphing the sine and cosine trig functions that we started in section 4.1. Remember, I mentioned in the previous section there were 5 different things we were going to change with the graph, and we've already done 3 of them. We could do a reflection about the x-axis, we could do an amplitude change, and we could do a period change. Those were the 3 things we changed in section 4.1. In this section, we want to continue looking at the sine and cosine graphs, but we want to change 2 other things possibly, and that's doing a horizontal shift and or a vertical shift. You did these in college algebra, so let me just refresh your memory how those work. So, for example, suppose we have the function y is x cubed minus 6x plus 4. So this is a cubic function, and I'm not concerned about what the graph looks like. But remember, if you wanted to move a graph to the left or the right, everywhere there was an x, you replaced it with x plus a number or x minus a number. For example, in this function I've created here, everywhere there's an x, if I replace x with x plus 3, so I've replaced that x with x plus 3 and that x with x plus 3. Now these are not the same function, it's a different function, but the graph of this second one will be a shift to the left of 3 units compared to this one. So if we replace x with x plus 3, that will shift this graph to the left 3 units compared to the original graph. Likewise, here's a natural log function. Again, I'm not concerned about the graph of natural log, but if everywhere there's an x, if we replace it with x minus 2, so I replace the x here with x minus 2, that's going to shift the graph of natural log of x to the right 2 places. So again, it's x minus 2, you replace x with x minus 2, it's going to shift the graph to the right. It's sort of the opposite of what you think it's going to be. Now this is true for any function, not just functions you studied in college algebra. It's also going to be true when we study these trig functions. So let's do an example with the trig function. So the first example in your notes is 2 sine of x minus pi over 2. Now this is certainly different from all the functions we did in the previous section, but what function does it resemble from the previous section? It resembles 2 sine x, doesn't it? We know we can graph 2 sine x from what we learned in section 4.1. And notice, how do we get this function, the equation, from this one? Everywhere there's an x, and this one we already know how to do. We replaced it with x minus pi over 2. So that's going to be a horizontal shift to the negative, so it's shifting to the right. So that's one of the 2 new things in this section. Okay, so if you have an issue with the format it looks like, think about what it would have looked like in the last section. Imagine yourself replacing x with x minus a number, x plus a number, and that'll tell you your horizontal shift. Now in the book, I usually say horizontal shift because that's what you learn in college algebra. In trigonometry, a phase shift is what they use instead of saying a horizontal shift. So when you read in the book and it says phase shift, just beware that's a horizontal shift. Okay, I want to identify everything just like we did before. So the amplitude, again, and where do you find the amplitude? It's the absolute value of the number being multiplied by the trig function. There's multiplication here. The absolute value of 2 is 2. The number 2 is positive, so there is no reflection about the x-axis. Now what about the period? So this looks a little bit different from what we did in the previous section. Remember, to get the period of the sine and the cosine function, it's 2 pi, the original period, divided by the number we call b, which was the coefficient of the x term, of the x. And notice there's a 1 here and a 1 here. The coefficient of x is 1. So it's 2 pi over 1, which is 2 pi. Now, the book isn't trying to be clever here, but just for your information, if they had written sine of 3 times x minus pi over 2, but if you had distributed, the coefficient of the x would have been 3. Right? Or if they had put that on the inside and said, 3x minus something pi, then the coefficient of x is 3, so your b would be 3. Now, again, the book isn't doing this, but suppose they had given you a problem like this. Cosine of 2 times 5x minus pi. Notice, if you were to distribute the 2, the coefficient on x would have been 10, and your B value would have been 10. Again, the book is not doing that. Every single problem either has a number here or here, but not both. Just be aware if it had done that, the coefficient would have been 10 and B would be 10. Okay, but here, B is 1. If you multiply this out, the coefficient of x is 1. Okay, let's do our pieces calculation. Remember, for the pieces, you take 1/4 of the period, and that's 2 pi over 4, which simplifies 2 pi over 2. And notice that shouldn't surprise you. Remember, in our original sine graph, the pieces were pi over 2, and the period was 2 pi, but that's because B was 1, okay, just like it was in the original sine graph. Okay, so let's go ahead and sketch this graph. So the amplitude is 2, so the range is going to go from -2 to 2. Oh, I didn't identify everything, sorry. We also have the new thing. The horizontal shift is how much which way. We kind of already alluded to this earlier. It's pi over 2. It's x minus pi over 2 that's substituted for x, so it's 2b. Right. Please tell me how much and which way. So this is shift pi over 2 to the right. Okay. So normally in the last section when we did these graphs, remember I always wrote the 0 down here. I always wrote 0, and we added or subtracted pieces from the 0. I did that on every single example. I started with 0, added pieces, or subtracted pieces from the 0. Well, now we have a horizontal shift. So what we want to do is do the shift first. When you're doing these problems, you're following order of operation. So if you plugged in the number for x, what's the first thing you would do? You would subtract pi over 2. So we want to deal with the horizontal shift first. Okay? So I want to shift pi over 2 to the right. And when you're doing the graph, before I start writing on my graph here, you should compare your shift to your pieces. And we're going to see different examples of this, but notice the shift here is exactly the same as the piece calculation. So if I move over pi over 2 to the right, it's equal to 1 piece, so I don't have to leave a lot of room to do the graph. Okay? So let me shift pi over 2 to the right, so there's pi over 2. So from that new place, I'm going to add or subtract pieces. Now, I'm purposely, in all these examples, I'm purposely choosing numbers where the shift and the pieces have a nice relationship. They're either the same, or one's double the other, or triple the other, something like that. I'm trying to keep the numbers nice. Because if the pieces were pi over 5 and the shift was pi over 7, the scale is going to be almost impossible to get. So I'm trying to keep this nice, but I'm trying to teach you the procedure that would work in any problem. Okay, so I've shifted to the right pi over 2. From this new starting point, I'm going to add or subtract pieces. Well, because the pieces is the same as the horizontal shift. If I subtract a piece, I'm back at 0. If I subtract another piece, I'm at minus pi over 2. If I subtract another piece, that's 2 pi over 2, which is minus pi. And if you add a piece over here, it's pi. Okay, so let me see, I have 4 pieces, 1, 2, 3, 4 intervals, and notice from minus pi to pi, 4 pieces is a total distance of 2 pi, which better be in the period. As I mentioned in the last section, check that calculation. Make sure your 4 pieces of the total distance is equal to your period. Okay, so now let's sketch the graph. Always ask yourself at this point, what does the original sine graph do on the y-axis? The original sine graph crosses at 0, 0. However, in this graph, we shifted to the right pi over 2. So I'm going to move the point that normally would cross at the origin over to pi over 2. And as I head to the right, the sine graph goes up. So this is in the middle. As I go to the right, I have a high, and now I'm going to backtrack high, middle, low, middle, high. So that's the graph of 2 sine of x minus pi over 2. Notice, if you didn't have the equation of this function, you would look at this graph and think it's just a reflection of the cosine graph. And there's a relationship, obviously. If you look at the sine graph and the cosine graph, one is just a horizontal shift of the other. So it shouldn't surprise you that when we do shifts of sine graphs, you may get one that looks like the cosine graph or the reflection. So that's our first example. So let's go on to the second example in the notes. So the second example is y is negative cosine of x plus Okay, as always, let's do the identifying. So I will pause and let you write down. So what do you think the amplitude is? So think about it for a second. Okay, the amplitude is the absolute value of the coefficient of the trig function. This is -1 times cosine, so the amplitude is 1. The coefficient is negative, so there is a reflection about the x-axis. So for the period, this one works just like in the previous example. The coefficient of x, there's a 1 and a 1 there. The coefficient is 1, so the calculation is 2 pi over 1, which is 2 pi. And the pieces calculation, take 1/4 of the period, and you get pi over 2, just like in the last example. And then finally, right, we have an x plus pi. The original function we could have done in the last section was y is negative cosine x. That we could have graphed in the last section, but we've replaced x with x plus pi. So that's going to be a horizontal shift, pi to the, it's x plus pi, so it's pi to the left. So there's all the identifiers. Okay? So let's sketch the graph. The amplitude is 1, so the range is going to be from -1 to 1, just as before. And remember, the thing we have to deal with first is the shift, the horizontal shift. Notice here the shift is pi to the left, but how does the shift compare to the pieces? Notice the pieces is half of the shift. So you have to plan ahead, or you're going to have to do some erasing. For example, suppose I said, let's shift to the left pi, and I just, on my picture, don't do this on yours, suppose I just went to here and moved over a little bit for pi. Well, then you look at your pieces is half the shift. So when I add a piece to this, it's going to put me right here, halfway to the origin, like right here, and there's not enough room to do your graph. So please try to plan ahead, or if you don't, erase and make it look presentable. So the shift is 2 pieces, so I'm going to, when I do my shift to the left, I'm going to leave a lot of room. So if I shift to the left pi, I'm going to come and say out here, there's minus pi. So I left a lot of room. So realizing that this shift is 2 pieces, I know when I add a piece, I'm going to be halfway. And if you add half pi to minus pi, you're at minus pi over 2. You add another pi over 2, you're at 0. Add another pi over 2, you're at pi over 2. Add another pi over 2, you're at pi. 1, 2, 3, 4 pieces. The distance from minus pi to pi is 2 pi, and that's what we said the period is, so we're good. Now we're ready to sketch the graph. So what does the original cosine graph do on the y-axis? It crosses at 0, 1. But that got shifted to the left pi, so the point that would be here got moved over here. But be careful, that's not where the point lines up. There's also a reflection. Remember, we had a reflection, so that reflects over the x-axis to -1. Let me do that one more time. So the original cosine graph crosses the y-axis at 0, 1. We did a shift to the left pi, so that puts that point here. And then we reflected the point about the x-axis, which puts it down at -1. So that's a low, and so that's a middle, a high. There's your graph of negative cosine x plus pi. And you probably noticed that this, if I didn't tell you the original equation, you would just say this is the original cosine function, which is exactly what it looks like. So notice if you take the original cosine function, shift it to the left pi, and then reflect over the x-axis, it looks like what you started with. So that's our second example. Now there's one little extra thing we have to worry about when doing horizontal shifts. So before we do the next example in the notes, suppose I have the function y is sine of 3x. Again, this is one we could have done in the last section. There's no horizontal shift here. Right? Suppose I wanted to shift the graph of this function to the right pi over 3. Well, what would the equation of that function look like? Well, everywhere there's an x, you would replace it with what? Okay. So if I'm shifting to the right, you want to replace x with x minus the number pi over 3. X minus pi over 3. Now again, these are not the same functions. This one, the graph of this function, it's a shift to the right pi over 3 compared to this one. Now if you wanted to simplify this, you could distribute the 3 into the parentheses. You get 3x minus 3 pi over 3 is just pi. Okay, now be careful. These two functions are exactly the same. All I did was distribute a 3. And I said to here, how does this graph compare to this one here? This is a shift to the right, pi over 3 of this one. These two functions are exactly the same. All I did was distribute the 3, which means this function is also a shift to the right, pi over 3, compared to this one. So you have to be careful. If you have a function that's written in this form, you can't just look at the number here to determine the horizontal shift, the phase shift. It's not pi here, okay? You have to factor the 3 out to make it look like this. You have to have x plus a number or x minus a number to be able to figure out the horizontal shift. So if you had this problem and you said the shift, horizontal shift, was pi to the right, that's going to be wrong. That's not correct. You have to factor the 3 out and then identify the horizontal shift amount from that number. So you have to be careful. That's really the first thing you should do when you do all these problems, okay? Look first to see, do you have to do any factoring? So if the problem looks like this and you have a 1x here, you don't have to do any factoring. But if you have a, like this, a 3x minus pi, you have to factor the 3 out and make it look like this. Okay, so the next example deals with that. Let's say, yes. So let's look at y is 3 cosine of 2x minus pi over 2. So that's our next example. So this is precisely what I was just referring. If you look at the function here, I have the angle is 2x minus pi over 2. The phase shift, the horizontal shift, is not pi over 2 because it's not just x minus pi over 2. We have to factor this 2 out so that if you're running a checklist of steps, the first step in all of these problems is, do you have to factor out? Now, if there's no horizontal shift, you don't have to worry about factoring. Okay, it'll look just like it did in the previous section. But here we need to factor out a 2. Now, when you factor a 2 from 2x, you're left with x. And then minus. Now, be careful here. This 2, that's 2 over 1. And this is pi over 2. The 2 is in the denominator here. The 2 is in the numerator here. There's no 2 in the numerator to factor out. Okay? So how does that go? Well, let me just make up an example with numbers to help you. Suppose I had 7, and I wanted to write that as 2 times something. You want to factor a 2 out of the 7, but there's no 2 that factors out evenly. So what do? You're pulling a 2 from a numerator, which it doesn't have. So you put in the 2 in the denominator to adjust for it. Notice the 2's cancel and you're left with your 7. So if there's not a number in the numerator, to put like the 2 here is in the numerator, there's no 2 to factor out. So what do? You adjust for it in the denominator. So let me do one more like that. So suppose I had 5 and I wanted to factor out a 3. Well, there's no 5, there's no 3 in the 5, an even factor to pull out. So what do? You have to adjust for the 3 in the denominator. Notice the 3's cancel and you're left with 5. So that's what we have to do here. There's no 2 in the numerator to factor out, so we have to adjust for it in the denominator. There's already a 2 in the denominator. When you multiply by another 2, you get 4. Now, always check your factoring by remultiplying to make sure you did this step correctly. So 2 times x is 2x. 2 times pi over 4, again, think of that as 2 over 1. So that's 2 pi over 4, which simplifies to pi over 2, and we did it correctly. Now we're ready for identifying. So the first step is, do you need to factor? And now we're going to do our identifying. So pause the video and see if you can do the identifying, and then I will do it, and we'll see if we get the same answer. Okay, so the amplitude here is 3, because 3 is being multiplied by cosine. There is no reflection about the x-axis because 3 is positive. The period is 2 pi divided by the coefficient of x. Either you can get it from here or here, that's 2. So the period is pi. And then the pieces calculation is 1/4 of the period, and that gives you pi over 4. So the only thing left to do is worry about, is there a horizontal shift? And there is, because we have x minus pi over 4. A horizontal shift is pi over 4. It's subtracting, so it's easy to subtract. Notice if you had not done the factoring step, you might have said the horizontal shift is pi over 2 to the right, which would have been incorrect. Now we're ready to sketch the graph. Notice the horizontal shift and the pieces are exactly the same here, so we don't have to leave ourselves a lot of room. We don't have to worry about that. The amplitude is 3, so the range is from -3 to 3. We have a horizontal shift of pi over 4 to the right, which is the same as the pieces calculation. So I'm going to move just a little bit, a reasonable amount to the right, pi over 4. So that's my new starting point. From here, I'm going to add or subtract pieces. Again, the pieces and the shift are the same, so if I subtract a piece, subtract pi over 4 from pi over 4, you're at 0. I'll just keep going to the left. Subtract another piece, you're at minus pi over 4. If I subtract another pi over 4 from minus pi over 4, you're at minus 2 pi over 4, or minus pi over 2. And if I go back to the right and add a piece, you're at pi over 2. Again, from the shift point, just like in the last section, I don't care if you go 4 to the right, 4 to the left, 3 and 1, 1 and 3, or 2 and 2. I don't care. Just do 4 consecutive pieces. But you have to remember, that's why I have you identify. You have to remember where you shifted to. So that's why I want you to identify. So we have 1, 2, 3, 4 pieces. From minus pi over 2 to pi over 2 is the total distance of 2 pi over 2, or pi, which is what we said the period was, so we're good. So now at this point, you ask yourself, what does the original cosine graph do on the y-axis? It crosses at 0, 1, but the amplitude is 3, and we shifted to the right pi over 4, so that puts that point here. We didn't reflect, so that's going to be here. That's a high, so the middle here, middle, low, middle. And that's the graph, 3 cosine of 2x minus pi over 2. So there's 3 examples with a horizontal shift. Now the last item, so now we've done 4 things to the graph: period change, amplitude change, reflection about the x-axis, and a horizontal shift. The only thing left to do is to do a vertical shift. Now let me go back to college algebra for a second. Suppose we have the function y is x squared plus x. The graph of that is a parabola that's opening up because the coefficient of x squared is positive. And remember from college algebra how you made a graph shift up or down. All you had to do was add or subtract a number from the function. For example, if I take this function and and just add a 3 to it, so that's my original function plus 3, that will shift that original graph up 3. So we'll just take the graph, that parabola, and it'll move it up 3. Now be careful. It doesn't have to be on the right-hand side. This is the exact same function as this. So be careful. If you're adding 3 here or adding 3 here, that's going to shift this graph up 3. That's why when I said in the last section, be careful about thinking about the number in front of the trig function. Because students will see this number here and say, well, it's in front, and therefore it's an amplitude change, and that's not what it is here. So be careful. Likewise, suppose I have this function, y is e to the x, the exponential function that you learned in college algebra. Suppose I wanted to move the graph of this function down 4 units. Well, what could you do? Right? You just subtract 4. So this will move the original graph I just had down 4 units. And like I said on this example, be careful. The number doesn't have to be over here on the right. e to the x minus 4 is the exact same as negative 4 plus e to the x. You're subtracting 4 in both of these cases. Now be careful. Don't focus on the plus sign. That doesn't mean you're moving up. The 4 is negative, so you're adding negative 4 to e to the x, which is the same thing as subtracting 4. So you'd be moving down. Okay, so let's do an example with our trig functions that have vertical shifts. So the first example in your notes is negative 2 cosine x minus 3. Now here, be careful as well. Your eyes may try to group this x minus 3 together as one term, but be careful, they're not. Order of operations is do the cosine of x. Order of operations is multiply by negative 2 and then subtract. So this negative 3 is not part of the x, it's not part of the angle. The angle here is x, and that's it. So this is going to be the vertical shift, because you're not subtracting 3 from the x, you're subtracting 3 from this whole thing. So let's do the identifying. So the amplitude is 2, the absolute value of the coefficient of cosine. There is a negative being multiplied, so that's a reflection about the x-axis. Notice the period here is 2 pi divided by the coefficient of x is 1, so that's just 2 pi. The pieces is 1/4 of the period, which is pi over 2. Notice our period and pieces are just like the original cosine graph because it's a 1 here. There's no horizontal shift, right? The angle here is just x. It's not x plus a number, x minus a number, so no horizontal shift. If there's no horizontal shift, you don't have to write it. But we do have a vertical shift, and always tell me how much in which way. This is down 3 units. Okay? Unlike the horizontal shift, the plus and minus makes sense. When you subtract a number, you go down. When you add a number, you go up. For the horizontal shift, it's kind of the opposite of what you think. Now, I'm going to do the graph in 2 steps here. Just adding this one extra step, I have a tendency to mess it up, and I suspect you will too. I highly, highly, highly recommend ignore the vertical shift. Do the graph of just minus 2 cosine x. Do that graph first. Then, when you have that graph, move it down 3 units. If you try to do it all in one step, I see students all the time, they get their graph is all cattywampus. It's crooked, they don't have the highs in the same place and the lows in the correct place. So I highly recommend just graph this like we did in the last section, and then do the vertical shift at the very, very end. So you deal with horizontal shifts first, you deal with vertical shifts at the end. So there's no horizontal shift here, so I'm going to start building from 0, just like we did in section 4.1. So I need to add and subtract pieces. I'm just going to do the numbers we had originally when we did the original cosine graph. I'm going to add pi over 2, add another one, you're at pi, subtract a piece, you're at pi, minus pi over 2, subtract a piece, you're at minus pi. 1, 2, 3, 4 pieces from minus pi to pi is a total distance of 2 pi, which is the period. Now something else that you have to plan ahead for, which I haven't yet, and I should have, is the amplitude of this graph is 2, so the graph is going to, without a shift, a vertical shift, we're going to run from minus 2 to 2. But then we're going to move down 3. Luckily, I've left myself room to move down, but you need to plan ahead before you start sketching the graph. And notice in all the problems we did before, I never put a scale on the y-axis. I just put the maximum and the minimum. But since we're going to be moving down, I really need to put more tick marks in here. So the amplitude is 2. So without doing the vertical shift, I'm here at 2 and down here at minus 2. And notice I have room to move the graph down later. So let me sketch that without the vertical shift. So the original cosine graph crosses the y-axis at 0, 1. But we did a reflection, so that point comes down here to minus 1. And there was no horizontal shift, so that's the point right here. Now that's a low, so that's the middle. Sorry, I didn't change the amplitude. Negative 2. So that's a low, that's a middle, that's a high. High, middle, low, middle. Let me double check myself since I put the point in the wrong place. So the original cosine graph crosses at 0, 1, but the amplitude is 2 here, and that got reflected to here. There was no horizontal shift. That's right. So that's a low, middle, and high. So this does like this. Now, this is the graph of y is -2 cosine x. So that's everything but the vertical shift. I did everything but the vertical shift. So now I'm going to use a different color. I need to take this graph and move it down 3 units. So I'm just going to take the important points that I've exaggerated here and move each of them down 3. So if I move this point down 3, it's 1, 2, 3. It's here at -1. This point is going to go down to -3. This point goes down to -5. This point goes down to -3. And this point goes down to -1. So just take each of your important points you put here and move them down 3 and resketch. So something like this. And so this is the graph of y is -2 cosine x minus 1. Now, if you look at the final answer, the actual graph here, I often will ask students, what's the amplitude of this graph? And they will say 5 because it crosses here at -5. That's not the amplitude of this graph. We said the amplitude was going to be 2. You don't just look at the number here. Now that's what we did in the last section before we moved up or down. Remember the definition of amplitude? It was the distance from the middle range value to the high or to the low. So notice the middle values here are at -3, right? I'm not going to draw this in, but if you put a little dashed line here, how far would it be from that dashed line to the top of the hill? It's 2, right? From -3 to -1, that's a distance of 2, which is what we said the amplitude was. And from the middle to the low value, that's also a distance of 2. The amplitude is still 2. Amplitude is not from here to here, right? Or just the number that, the high or the low. It's the distance from the middle to the high or the middle to the low. So that's the answer to that problem. So the next problem is a little more complicated. I keep adding more and more things each time we go. So y is -5/2 plus cosine of 3 times x minus pi over 6. So while I erase here, think about what's the first step in this whole procedure. Think about the very first step, what you should do first. Okay, so did you say to yourself, the first thing you need to check is, do we need to factor? That's the first step. Notice if you look here, the coefficient of the x inside the parentheses is 1. The 3 has already been factored out. So you don't have to do anything, but you have to check that step just in case you need to. So we don't actually have to do the factoring. It's already been done for us. Okay, pause the video and see if you can do all the identifying. Remember, amplitude, reflection, period change, horizontal shift, vertical shift, and the pieces. So pause the video and do that, and then I will do it. We'll see if we get the same answer. Okay, so where's the amplitude here? Be careful. It's not the number sitting out front. It's the coefficient of your trig function. It's the number being multiplied by the trig function. -5/2 is being added to the trig function. That is not the amplitude. The amplitude is sitting right here. It's 1. 1 times cosine. And because that coefficient is 1, there is no reflection about the x-axis. Okay, now what about the period? And the period, as always, is 2 pi divided by the coefficient of x, which is 3. And then the pieces, it's 1/4 of that period, which is 2 pi over 12, which gives me, when you simplify it, pi over 6. So there's the pieces calculation. Now, is there a horizontal shift? Well, we are subtracting pi over 6 from the angle x. That's a horizontal shift of pi over 6 to the, it's x minus pi over 2, and so it's to the right. And then we also have a vertical shift, and that's coming from this number. Again, we could have written this -5/2 out here as -5/2. this is going to go down 5/2. Because I know it's a plus here, but the plus is with the amplitude, the minus is here. You're subtracting 5/2, so we're going to go down 5/2. So when I set up my graph here, I'm going to move down 2.5, so I need to give myself room. So I need to draw my graph up here. Notice also the shift and the pieces are exactly the same, so in terms of going a horizontal shift, you don't have to leave a lot of room. Okay. So I'm going to graph the function cosine 3 times x minus 5/6 without the minus 5/2. Okay? So I'm not going to worry about the vertical shift. I'm going to do that at the very end. Okay, so what do we need to do? We normally start building from 0, but we have a horizontal shift, which is pi/6 to the right. So, and that's the same as the pieces, so I need to move pi/6 to the right. Just leave a little bit of room. And now from there, we're going to add or subtract our pieces, and my pieces are pi/6. So if I subtract pi/6 from pi/6, I'm at 0. Subtract another pi/6, I'm at minus pi/6. If I subtract another pi/6, I'm at minus 2 pi/6, or minus pi/3. And then we go back over here, if I add a piece, I'm at pi/3. Notice I'm adding and subtracting pieces from my shift point, which was pi/6 to the right. So I've added one piece to the right, and I went 3 pieces to the left. And my amplitude is 1. So without doing the vertical shift, I'm running from -1 to 1. Okay, and then at this point, you ask yourself, what does the original cosine graph do on the y-axis? The original cosine graph crosses at 0, 1. We did not reflect, but I'm shifting that point to the right pi/6, so that point comes to. And that's a high, and so I have a middle here, a low here, middle here. So this is the graph without the vertical shift. This is y is cosine of 3 times x minus pi/6. So that's the graph in black that I'm looking at. So the only thing left to do is shift this graph down 2.5. So let me add some, there's one. I'm making that mistake. Okay, so let's move this graph down 2.5. I'll do it in blue. So 2.5 down here is going to be here, 2.5. From -1, it's going to take me down to -3.5. 0 take me down to -2.5. 1, if you go down 2.5, that's 1, 2.5. That puts me here, and then 2.5 down there. So it does this. So this is y is -5/2 plus cosine of 3 times x minus 5. And look and see if your graph here has the same shape as the one here. I'll have students that do this, and then this one they put like here, and the hills are a lot higher than the valleys are low. So try to make sure that they sort of have the same distance apart. So that's that one. So the last example in this section, and I've noticed that, I've noted it in the notes, this has every possible thing in it. Now, on a test or quiz, I normally do not give a problem that has everything in it, because if I have 2 or 3, 4 graphing problems, on one of them I may have a horizontal shift, an amplitude change, and a reflection. And then the other one I may have a vertical shift and a period change. Okay, so I usually don't ask everything in one problem. But if you can do this problem, then you understand what's going on. Okay, so as we've done before, go ahead and pause the video and do all the identifying on this problem, and then I will do it, and we'll see if we get the same thing. Okay, so the first thing you should have done is realize you need to factor. okay? It's not x plus a number, x minus a number, it's 2x. So we have to factor out the 2. So it's 2 times x plus something. Now there's no 2 to factor out from the pi, so remember how we adjust for that. You have to put a 2 in the denominator. And check your factoring by remultiplying. Always, always, always. 2 times x is 2x. 2, that's 2 over 1 times pi over 2. The 2's cancel and you're left with pi. Now let's go ahead and finish the identifying. So the amplitude here, it's the absolute value of the coefficient of the sine function. So the coefficient's negative 2. So the amplitude is 2 because it's the absolute value. But the negative there means reflect. We cannot combine the 4 and the 2, okay? You cannot simplify that to a single 2 because of order of operations. You have to multiply the 2 first, then do the 4, okay? So you can't combine those. Now what about the period? The period is 2 pi, the original period, divided by the coefficient of x, so that's 2, which is pi. And then for the pieces, you take 1/4 times the period, and you get pi over 4. So that's everything from the previous section. Now we have a horizontal shift, a phase shift, of how much which way. Don't use this one, it's from this one. It's pi over 2 to the left. And we have a vertical shift. Now, did you say the correct number here? It's 4, but is it up or is it down? Be careful, the negative is on the 2. That was for the reflection. This is 4. You're adding 4 to the rest, so you're going up 4. So there's definitely a lot going on in this particular problem. So when I do the graph, I'm going to do everything but the vertical shift, but let me plan ahead. I have to move up 4, so I need to give myself room to move up. So let me put the x-axis down here, give myself some room. Now what else should we look at? Let's also look at how the shift compares to the pieces. A piece is pi over 4, the shift is pi over 2. The shift is double that of the pieces. So when I shift left pi over 2, I'm going to give myself room for 2 pieces. So if I move left pi over 2, I'm going to give myself room for 2 pieces. So I know there's 2 pieces here. And if I add pi over 4 to pi over 2, well, that's going to put you at minus pi over 4. It's halfway. Add another pi over 4, I'm at 0. Add another pi over 4, I'm at pi over 4. Add another pi over 4, that's 2 pi over 4 for pi over 2. I have 1, 2, 3, 4 pieces. And the total distance from minus pi over 2 to pi over 2 is a distance that's 2 pi over 2 for pi, which is what I said the period was going to be. The amplitude is 2. Again, I'm going to include a scale because I'm going to move up. So 1, 2, and then minus 1, minus 2. So I'm graphing everything but the vertical shift. Ask yourself, what does the original sine graph do on the y-axis? It crosses at 0, 0, and that got shifted to the left pi over 2. So this point gets moved to minus pi over 2. And as you head to the right, the original sine graph goes up. However, in this problem, we reflected, so from this point, our shift point, instead of going up when we go to the right, we're going to go down. So this is a middle, this is a low, that's the middle, that's a high, that's middle. Okay. So this is y is negative 2 sine of 2x plus pi. So it's everything but the vertical shift. I haven't done the vertical shift yet. And now we just have to take all these important points and move them up 4. 6. So this point, the y value is 0, so I'm going to move that up to 4. That's the middle of 4. Negative 2, 1, 2, 3, 4. 0 goes to 4. 2 goes up to 6. 0 goes up to 4. So this is the graph y is 4 minus 2 sine of 2x plus. Again, it looks like I kept the common distance all the way through, so that looks okay. So that was the last example. Again, if you can do this problem on your own, it has everything in it, that means you kind of understand what's going on. Just be aware, in the homework, they're asking you to sketch 2 periods of the graph, and I think they said the same thing in the last section. I'm perfectly happy with 1 period of the graph. If you do want to do 2 periods for practice, what do you need? You're going to need 8 pieces. So you have to, from your shift point, add or subtract either way to get a total of 8 pieces, not just 4. But I'm perfectly happy with 4, and on the test or quiz, I'll ask you for 1 period as well. So that's how you graph everything with sine and cosine: period change, horizontal shift, vertical shift, amplitude change, and reflection over the x-axis. Those are the 5 things now we know how to change. So in the next section, we're going to do the same sort of thing with the tangent and the cotangent function, and so that's what the next video will be about.